Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome back to my YouTube channel. Don't forget to subscribe, comment, and like this video as much as possible. By the way, hi, introduce, my name is Titania Yushinta. I came from class D for Electrical System 3B with absent number 22 and student identification number 18411500134. In this video, I will explain and present a PowerPoint. This is my PowerPoint. In this video, I will explain and present a PowerPoint entitled Electrical Instrumentation of Steam or Gas Turbine with Power Generator. And then, of course, we also get this material from the lecture, namely Bapak IRWAN HERYANTO ERYK, ST, MD. See, he is my lecturer. What will be discussed? Number 1, introduction and definition, and then purpose, and then steam turbine components, and then steam turbine working principle, and then turbine controller system, and then protection system on the steam turbine generator, and then performance evaluation of more flow. Okay, the first one we will present is introduction and definition. The steam turbine is a prime mover that converts the potential energy of steam into kinetic energy and then converts it into mechanical energy in the form of turbine shaft rotation. The turbine shaft directly or with the aid of a reduction chair is connected to the mechanism to be driven. Depending on the type of mechanism used, steam turbines can be used in various fields such as industry, for power generation, and for transportation. In the process of changing potential energy into mechanical energy, namely in the form of shaft rotation, it is carried out it variant-wise. Basically, a steam turbine consists of two main parts, namely the stator and rotor, which are the main components of the turbine. The other components are which include support such as bearings, couplings, and other auxiliary systems so that the turbine works better. A steam turbine utilizes the kinetic energy of the working fluid, which is increased by the addition of thermal energy. Gas power PLTG in an electric energy generator that use gas turbine equipment or engines as generator. Gas turbines are designed and made with a simple working principle where the heat energy generated from the combustion process of the fuel is converted into mechanical energy and subsequently convert into electrical energy or other energy according to their needs. The PLTG system used to Brayton cycle principle, which is divided into open and closed cycle. You can see the picture below. Part of PLTG. Before part of PLTG, generally PLTU use a multi-stage type of steam turbine, namely a steam turbine consisting of more than 8 turbine stages, high pressure, intermediate pressure, and low pressure turbine. The superheater water vapor produced by the boiler enters the high pressure HP turbine and exits of the exhaust sides to the boiler again for the reheat process. This reheat water vapor is fed back to the intermediate pressure or IP steam turbine, and the steam coming out of the IP turbine will go directly to the low pressure or LP turbine. Furthermore, the water vapor coming out of the LP turbine enters the condenser to undergo a condensation process. And then part of PLTG. Number 1, transfer pump. A pump that serves to move that fluid in the form of HSP from the tank to the combustion chamber. Number 2, combustion chamber. Combustion chamber that functions as a full combustion system in the gas turbine system. Turbine. Gas turbine whose function is to expand hot gas to produce mechanical energy to drive the generator. Number 4, compressor. Taking atmospheric air and turning into high pressure air to assist the combustion process in the combustion chamber. The compressor consists of an air filter, inlet quad fan or EDV, stack place and road place totaling 19 stacks. The function is to draw outside air into the combustion chamber as a combustion process and cooling media. Number 5, air filter for air filtering so that dust particles do not enter when inserted into the compressor. Number 6, gas line in the path of gas passing. Number 7, electric power diesel with function to produce mechanical power that is used to rotate the generator rotor. Number 8, stocks, which is useful as a distribution of exhaust gas. Number 9, transformer function to increase and decrease the voltage. Plus, number 10, main substation to distribute electricity. And then purpose. The purpose of this paper is to evaluate the performance of three types of overcurrent release of the generator if asymmetrical interference occurs at the generator terminal. This performance evaluation includes the pickup time and operating time of overcurrent relay. Evaluation is done by using the available relay, setting data, and the data generator use. And then to add insight which relate to the PLPG starting from how it works, what are the parts of the PLPG, then the advantages and disadvantages of the PLPG, especially for our important part of the PLPG, namely turbine. Next, steam turbine components. Number 1, shaft seal. The shaft seal is part of the turbine between the shaft and the casing which function to prevent water from leaving the turbine through the gaps between the shaft and the casing due to pressure difference and also to prevent air from entering the turbine, especially LP turbine due to higher water vapor pressure vacuum, where the steam turbine is operating. Number 2, turbine bearings. Turbine bearings. Bearings on steam turbine have the following function. Hot rotor component actually withstand the weight of the rotor, resistant to various unstable force from water vapor to turbine blades, and resist the kinetic force due to residual imbalance or imbalance due to blade damage or anticipation. And then last, with up axial force under varying electrical loads. The type of bearing in use to design of steam turbine are tooth bearing, channel bearing, and a combination of the two. In addition, a lubrication system using oil is also needed, which is consistently circulated and cooled to lubricate the bearings that continue to experience friction when the steam turbine is operating normally. And then 3, balloon piston. Balloon piston is a steam turbine. There is a 50% reaction force from the rotating blades producing an axial force against the right side of the turbine per cylinder. This force that the balloon piston system needs to resist. You can see the picture below. And then turbine stop valve and turbine control valve. Turbine stop valves are also called emergency stop valve because its function to isolate the turbine from the steam supply in an emergency to avoid damage or also overspeed. And then turbine control valve serves to control the supply of water vapor that enters the turbine in accordance with control system that depend on the amount of electrical load. And last, number 6, turning device is a mechanism to rotate the rotor of the turbine at the time of initial start or at the time after shutdown to prevent distortion or bending due to the heating or cooling process that is not uniform in the rotor. You can see the picture below. And next, steam turbine working principle. The steam turbine consists of a disc surrounded by disc plates called plates. These plates rotate due to the blowing of pressurized steam coming from the steam boiler. This has been preheated using solid, liquid, and gas fuels. The steam is divided using a control valve which will be used to rotate the turbine, which is coupled directly to the pump and also coupled to a synchronous generator to produce electrical energy. After passing through the steam turbine, the high pressure and high temperature steam appears to be low pressure steam. The heat that has been absorbed by the condenser causes the steam to turn into water which in the pump back into the boiler. The remaining heat removed by the condenser reach half the amount of the original heat entered. This results in the thermodynamic infancy of a steam original heat entered. The result in the thermodynamic efficiency of a steam turbine being less than 50%. Modern steam turbine have boiler temperature around 5,000 Celsius to 6,000 Celsius and condenser temperature from 200 Celsius to 300 Celsius. And then turbine compiler system. Number 1, full oil system. HSD or high-speed diesel is used to fuel in the combustion system of this PL2GE. The combustion system starts from the stock tank HSD oil tank. It is pumped using a transverse pump through a flow meter to calculate its use. Number 2, loop oil system. Lubrication systems are used to lubricate gas turbine bearings generator, and also to supply oil to the hydraulic system at the main stop pump EUP. Main stop pump EUP is start to supply oil in gas turbine bearings and generator. Then the gas turbine is rotated at that tuning curve at 3 RPM. Number 3, hydraulic system. Hydraulic system is used to drive the main stop valve and the fuel valve HSD 1047 A and B 1035 ampere and the full gas valve 1017 and 165, where the main stop valve serves to stop the flow rate of fuel oil when the unit occurs interruption and or to open fuel lines in the piping system full. Number 4, cooling system. The head temperature of the lubricating of oil being used to lubricate the bearing turbine and the bearing generator will enter the loop oil cooler to be cooled by the lubricating oil cooling system with the cooling medium is water. Number 5, starting system. Start system equipment in gas turbine is of a prime mover. This is necessary because at the start the turbine condition is still not able to move the generator and compressor because it has not yet ignited. Number 6, fuel for PLTG operation. The fuel used in the form of diesel fuel HSD or high-speed diesel is flowed from the tanker into the HSD fuel pump house, the pumped again with a fuel pump to be included in the combustion chamber so as to produce gas turbine rotating energy. Number 7, combustion chamber. The combustion chamber is the room where the combustion process takes place. The initial energy of the fuel is converted into thermal energy in the combustion process. Number 8, generator. And number 9, turbine. Generator, the function of the generator is to change the mechanical energy of the rotation in the rotor contained by the magnetic pole into electrical energy in the stator coil. And turbine serves to convert thermal energy from combustion result in the combustion chamber into kinetic energy in a fixed bed and into mechanical energy in a root plate so that mechanical energy will rotate the turbine shaft. And then video, this is protection system on the steam turbine generator. Number 1, interference or generator, interference with the stator, interference with the rotor, interference that cause abnormal condition, loss of excitation, overload, overvoltage, loss of prime mover, negative path clearance, overspeed, overtemperature, protection relay or steam turbine generator, overcurrent relay with voltage restraint, differential relay with stator, relative negative overcurrent relays, reverse power relay, stator differential relay, ground, loss of phase relay, valence voltage relays and time delay, relay overcurrent neutral generator, overvoltage relay, and last, thermal overload relay. And the next 4 point, performance evaluation of more flow. The performance of overcurrent relay referred to here is an evaluation of overcurrent relays on the generator when setting a trip signal in the event of these turbines. Okay, number 1 ada single phase interference, 2 two-phase ground discorder, and 3 two-phase interference. Okay, single pass interference. Pass ground disrupted include positive, negative, and zero sequence. Impedance connect as so in. You can see the picture below. And next, to pass ground discourse. To pass ground interference include positive, negative, and zero sequence. Impedance connect a sound in. You can see the picture below. And then to pass interference. To pass interference include positive, negative, and zero sequence impedance connected, and so in you can see the picture below. Work principle of PLTG. The work cycle of ordinary PLTG is called the Brighton scale. The Brighton scale can be seen as shown below. Number A, the cycle of PLTG like this one. First, the air impressed with the compressor into the combustion chamber. And then, in the combustion chamber, the air is spun with natural gas fuel. And then, burned air will produce gas with very high pressure and temperature. And then the gas is flowed into the turbine to turn the turbine. The generator is coupled directly with the turbine, so that in the turbine rotates. The generator rotates. Compressors are also sputtered with turbine, so the gas pressure generated from the combustion chamber in addition to turning the turbine is also to rotate the compressor. And last, next, the gas from the turbine is thrown back into the air. Open Brayton cycle gas turbine. Fresh air in the ambient condition atmosphere is sucked into the compressor where there is into increase in temperature and pressure. Air processes in the combustion chamber where fuel is poured and constant pressure, the high temperature gas projects the enter the turbine, where the high temperature and fuel are burned and atmosphere pressure so that it produces power. The exhaust gas produced by the turbine is discharged out. And then closed cycle gas turbine. The working of closed cycle gas turbine as a whole are almost the same as open cycle, where the compression and expansion process remain the same, but the combustion process is replaced by a constant pressure heat input from an external source. And the exhaust process is replaced by a constant heat release at ambient temperature. Advantage and disadvantage of PLTG. The advantage PLTG, easy and cheaper installation process, fast start up time. Emergency power or backup. Can use a varied or variation full electrical capacity is more varied, more environment when compared to PLTU. Higher efficiency, lack of PLTG, usually only to meet peak power, and noise pollution had her operational costs. And then, conclusinya, this is based on the performance evaluation study of 3 tips or overcurrent relay installed on the generator, it can be concluded that overcurrent protection on the generator is got because for each type of overcurrent relay interface, the sense or trip signal. With the attempt operand stem as follows for single pass interference and for pass A phase B interference to the ground and last for pass A phase B interference. Okay guys, I have finished the explanation and presentation that I explained. I hope you understand about electrical instrumentation of steam or gas turbine with power generator. I hope it adds to your insight and knowledge. If there is a wrong word and lack of explanation, I apologize profusely. See you in the next video. Don't forget to subscribe, comment, and like this video as much as possible. Wassalamualaikum warahmatullahi wabarakatuh.